Hi everyone, you are welcome to DML Physics Concept. Alright, today we'll continue from where we stopped last class. Last class we started by looking at vectors and scalar quantity. We defined vector quantity and scalar quantity, and we've started addition of vector quantity. So we looked at how we are going to add vectors depending on how they are acting. If they are acting in the opposite direction or different direction or 90 degrees to each other or at angle theta to each other. So let's quickly go a little recap before we now move to the next case and continue from where we stop. So we said that if they are moving in the same direction, our resultant is going to be F1 plus F2. We also say that if they are moving in opposite direction, our resultant is going to be F2 minus F1. So depending, this one depends on the one that is greater. It's not necessarily F1 minus F2 or F2 minus F1. Just remove the smaller value from the higher value. Then when the vector is acting at 90 degrees to each other, we said our resultant is going to be the square root of F1 square plus F2 square. And we said that if vector is now acting at angle theta to each other, we use the parallelogram law, which is r square equals to F1 square plus F2 square minus 2F1 F2 cos theta, whereby it's 180 minus theta, whereby this theta is the angle between the two forces acting together. So today let's proceed from where we stopped in the last class. Alright, let's find the resultant of these two vectors F1 and F2, 3 Newton and 4 Newton, that is acting at 120 degrees to each other. The previous one we did was when they are acting at 60 degrees to each other, which is acute. So if you don't have access, if you want to go over that video, I will drop it in the description link. Make sure you go to that video and watch the video to get a better understanding of what we are doing now. Now let's look at how to do this. We are going to solve this one using the parallelogram law, which says we should first complete a parallelogram, and after we have completed the parallelogram, so this is a parallelogram, make it a parallelogram. So the next thing is we have to draw a diagonal from the point of intersection. This is the point of intersection. We are going to draw the diagonal. So this diagonal is representing our resultant vectors. Now if this one is 120 degree, and it means this one is corresponding angle. So this one is also to be 120 degree because these two angles, they are corresponding. So therefore this angle here is going to be 180 minus theta. And 180 minus theta, whereby your theta is 120 degree. So let's take it out now. So it's going to look like this. So we're going to have something that looks like this. So this is our resultant vector, and this one is going to be 180 minus theta. If theta is 120, so 180 minus 120 is going to give me 60 degree. So this is 4 Newton. This side is 4 Newton. Remember, our vector is acting this direction. And then we have this one and this one, since they are parallel, so they are acting the same way. So this is also 3 Newton. So let's find our resultant now using our parallelogram law, which says r square is going to be a square plus b square minus 2ab cos 180 minus theta, whereby the theta is the angle between the two forces. So our r square equals to a square and b square. Remember, a square and b square is the first f and the second f, which is 3 and 4. So you just say 3 square plus 4 square, then minus 2ab, that is 2, 3, then multiply by 4, cos 180 minus theta. Theta is 120, which we have gotten to be cos 60 degree. So if we now have that one, so let's begin to solve for that. The r square is going to be 9 plus 16 minus 2 times 3, 6 times 4, that's minus 24 cos 60. So let's solve now. Then our r square is going to be 25 now minus 24 cos 60. So let's look at it now. What's going to be cos 60? So cos 60 is 0.5. So r square equals to 25 minus 24 into bracket 0.5. So in this case, our r square is going to be 25 minus, if I multiply this one, it's going to give me 12. So it means my r square is going to be, what is 25 minus 12? The 25 minus 12 is going to give me 13. So r, which is our resultant that we are looking for, is the square root of 13. And what's going to be the square root of 13? So the square root of 13 is approximately 3.6 Newton. It's approximately 3.6 Newton. So let's look at the direction now. So how do you get direction? Remember, the direction is always angle between the resultant and the horizontal. This angle. The angle between the resultant and the horizontal. This is the horizontal side. So let's look at that. How far? We just say A over sine A equals to B over sine B. So where is our A? Our A is going to be 3. And what is sine? That is sine of alpha equals to our B. Our B is R. And we have gotten our R to be 3.6 over sine B. And B is 60 now. So let's find our alpha from here. We can just say sine alpha. If I cross multiply, then sine alpha is going to be 3 sine 60 divided by 3.6. So our sine alpha is going to give us, so let's just press calculator and get a straightforward answer. So it's going to give us 0. Everything like that. If I divide it by 0.77216. So let's find our alpha now. Our alpha is going to be sine inverse of 0.7216. So what's going to be our alpha if I press the sine inverse? So our alpha is going to be 49.2 degree. So if I ask us what is going to be the resultant is 3.6 Newton, while the direction is 49.2 degree towards the horizontal. So make sure you go over these examples and go over the previous classes as well for better understanding. So the next thing we want to look at is when we now have vectors that is more than 2. These are just 2 vectors. So when we have more than 2 vectors, then we are going to do what we call resolution of vector. We have to resolve the vectors into their various components. So that's what we call resolution of vectors. So let's look at the resolution of vectors. Now, we want to look at resolution of vectors. But one thing I want you to understand is that any vector quantities has 2 components. That is, we can resolve every vector quantities into 2 components. There is always a vertical component of the force, and there is always an horizontal component of the force. Now, what is the vertical component? The vertical component of the force is the effective value of that vector in that vertical direction. While horizontal component is the effective is talking about the resultant value of that force in the horizontal direction. So we have the vertical component of force, we have the horizontal component of force. Now, what's going to be the vertical component of force? Our vertical, let's look at an illustration. Let's say we have this chart, and let's say a vector moves in this direction. This is our vector force, which is our V. Let's call it our V. Sometimes we can call it F. It's a vector because of magnitude and direction. As we are looking at this vector, if this vector is at an angle theta to the horizontal, remember, angle, the direction of the vector is always angle between that vector and the horizontal. Alright, if the direction is at angle theta to the horizontal degree, now they can ask us to find what is the effective value of this vector in the vertical direction, what is the effective value of this vector in horizontal direction. So we have the vertical and then we have the horizontal. I want you to pay attention to this concept, because when we get to projectile, which is the maybe next topic I'll be looking at, we'll be talking about this component of force. So when an object moves in a vector moves in a direction, there's going to be a vertical component of that force, and there's going to be an horizontal component of that force. So how do you get the formula for the vertical or the formula for the horizontal? So let's do the way we have been doing. Let's complete this and make it a parallelogram. Let's just complete this rectangle. Let's complete it to make a parallelogram, or let's say square. So in this case, let's take this part out. So if I take this part out, I'm going to have something like this. So which means in this case, this is the angle theta. This is the vector we are looking at. This is the vertical component of the force. Let me call it a vertical component. Let's call it V, Y axis. And then we have the horizontal component of the force, V. Let's call it X axis. So how do we get the vertical component? How do we get the horizontal component? It's simple. So the vertical component with this vector is like opposite hypotenuse. So let's say we have opposite. To get the vertical component first, we'll be looking at the opposite. Remember, this is a 90 degree. Is the opposite, and this is the hypotenuse. So we are dealing with opposite and hypotenuse. Remember our SOHCAHTOA, which is our trigonometric ratio. So which means when we are dealing with opposite and hypotenuse, is going to be sine. So therefore we are saying sine of theta is going to be opposite, which is Vy, and hypotenuse, which is going to be our vector component V. So if I want to make Vy the subject of the formula, then I'll say Vy equals to V sine theta. So which means the vertical component of force, which is this one, is given as Vy is always V sine theta. So a vertical component of a force is V sine theta. Now let's look at the horizontal component of the force. If I want to know the horizontal component of the force is adjacent to this hypotenuse. So adjacent and the hypotenuse is going to be cos of theta is going to be the adjacent. The adjacent is the Vx, and the hypotenuse is the V vector quantity. If I make Vx the subject of the formula now, our Vx is going to be V cos theta. So the horizontal component of a vector force is given as Vx equals to V cos theta. So you don't need to just cram it, but you need to understand how we deduce that. So for every vectors that moves in certain direction, it can be resolved in a vertical direction or horizontal direction, because they always have that two component of force, which is the vertical component and horizontal component. Because as this object is moving up, it's covering certain ground vertically, it's also covering certain ground horizontally. So there is a vertical component of that force, and there is an horizontal component of that force that is given as that. So in summary, we can say vertical component of a vector is Vy is V sine theta, while Vx, horizontal component Vx, is V cos theta, whereby this theta is always the angle between that given vector and the horizontal. This is the given vector. So the angle between the given vector and the horizontal is going to be our theta. Alright, in the next class, we'll be looking at the resolution of the vector. So I don't want us to go too far. So in the next series, we'll be looking at how to resolve vector into vertical component, horizontal component, and especially when we have more than two vectors acting together. Thank you for watching this video. Don't forget to subscribe to this YouTube channel, like and comment, and at the same time share this video. Please share this video. Thank you for doing that, and God bless.